Part C, it may look nasty, but it says, show for all values of theta the point P with the position vector lies on the line through AB. So what we need now is the vector equation of the line that goes through AB for part C. So let's have a look at this vector equation here for the line through AB, just sort of picking up on that part of the question there. Vector equation of a line is R equals, and then what comes after the R bit? The R equals. Starting point. Do you know any starting point on this line AB? Yeah. This point here is on it. Okay, and then we'll put our S in. Except we might as well use we'll use the S, that's fine for now. Then what is this next bit here always? That's the position vector. This is the direction vector. Do we have a direction vector from A to B? Yeah, it's this bit here, okay? So we stick that in there. That's the equation of the line through AB. And what they're saying is for all values of theta, the point P lies on that line. Now, their thing with the I, J's and K's, if you write it out without the I, J's and K's, it's lambda I, 2 lambda J, and 2 lambda minus 9 for the next bit. And if we just put that equal to this, because it's got to be true, it's got to be on there for all values. Now, if we just go through here, effectively, it's almost like you can think of multiplying the brackets out. Here I've got 3 plus s times by minus 1. In other words, 3 minus s equals lambda. From the top line, that's from like the x component of the vector. Sorry, you didn't see that. That's 3 minus 1s equals lambda. That's the x component of the vector. The y component of the vector, 6 plus s times by minus 2 equals 2 lambda. These are s's here. Okay. Now if we just look at the top one here, if we know what lambda is, just work on the right hand side here. 2 lambda should be 2 lots of 3 minus s, which is 6 minus 2s. That works. That's okay. This is a showing question. We've got to show it works. Well, it's consistently true for there. And if we do now the z component bit, which would be minus 3 minus 2s equals 2 lambda minus 9. Well, if I use my definition of lambda from here, as long as it works in this one, I'm okay. I've showed it works, and it was a show question. So lambda should be equal to 3 minus s. So this should be 2 lambda minus 9. If you multiply that out, 6 minus 2s minus 9. 6 minus 9 minus 3 minus 2s, which is exactly what I got here. And because everything ties up, it's completely consistent, you have done that showing thing. It works, it fits in there for each component of the vector. And that's part C complete.